Hello, everyone, and welcome. My name's Todd. I work at Google. Today, I will be talking about machine learning outages and incidents, giving a talk entitled Nothing to Recommend It, an interactive machine learning outage fable. So the first part of the title, possibly straightforwardly enough. On the one hand, it is about a machine learning recommendation system, and so perhaps the title is just a cutesy play on words. It's also possible the title is self-documenting, that the talk itself has nothing to recommend it. That may also be true. If you find that to be the case, you can skip this session. I won't be upset. I won't even know. The subtitle is perhaps a little bit more interesting, an interactive machine learning outage fable. Let's work backwards. A fable is a story, and I will indeed be telling you a story. It is in particular a story that has some truth or gets at or conveys some truth, but is not itself literally true, that the things in the story of the fable did not happen. All of that is certainly true of this story or fable that I will be telling you, as will become fairly obvious as we get into the details. An outage is something wrong with our system not performing the way we wish it did. This is sloppier and fuzzier and messier in machine learning than it is in some other kinds of systems, and we'll talk about that a bit. Machine learning, because we're here to talk about machine learning. Nothing about this talk requires you know very much in particular about how machine learning works. So if you are just dipping your toes into the machine learning water, welcome. It's great to have you. Most of us also don't know really what's going on in any great level of detail. So you have plenty of time to catch up. We're going to be doing this for a while, this machine learning stuff. And you will always feel a little bit behind, as we all do. And we're just marching forward. So glad to have you here, sort of poking around and trying to figure it out with us. And interactive, this is hubris, foolishness, tomfoolery, and nonsense. There's literally no way this talk could be interactive. In particular, I'm recording it quite some time ahead of when you are watching it. So the degree of interactivity between us may require some fairly complex physics and a large supply of tachyons, neither of which we are going to be able to provide in these contexts. I can't comment on unreleased products, of course. But interactive, to the extent to which I will be asking questions, you will be giving answers, and I'm going to try it out. This is quite likely to not work, but I was told that I could try it, or I wasn't told I couldn't try it, to be more specific, and so I'm going to try it. I think it's going to be a lot of fun. We will have fun, at the very least, in the sense of I will have fun, you will laugh at me, thereby also having fun, and we will be having fun together in the broader sense of together. So with that said, let's get started. What is our agenda? I will be telling you a tale of sadness and woe. There's an online knitting and crocheting shop that sells yarn and other stuff related to knitting and crocheting. It's having some trouble. We're going to talk about that. We're going to talk about what happened. We're going to try to troubleshoot it together. You'll be doing some solving of puzzles on your own, at least 2 of them. And there'll be a 2-part quiz, as mentioned. And we'll try to learn from that what we can discern about machine learning outages more broadly and how they might differ from other systems kinds of outages. So with that said, let's do some quick introductions. The basics, this is the usual. Who am I? I'm a recovering systems and network engineer. I've been working on machine learning SRE at Google for a little over 12 years now, since before many people were serious about machine learning or serious about SRE. So that was pure luck, not foresight. Other people invented this stuff, not me. I did found and lead the machine learning SRE teams at Google, and also I'm the Pittsburgh site lead. That's a little bit different, but it does bring this glorious shirt for you here today. I'm currently writing a book on reliable machine learning for O'Reilly with a bunch of other people. We'll talk about that later, and there's a few chapters online. The single most important question, I can hear you asking it through time and space. What is the animal? We don't know the animal. The animal at this point has not been selected, I'm very sorry to say. Okay, good. Who are you? Or who do I imagine you to be? You know who you are, but I don't know who you are. I imagine you to be SREs who are at least curious about how machine learning incidents are different than other kinds of outages. I don't imagine you to be machine learning professionals or have PhDs in machine learning, or even necessarily know a lot about how machine learning works in general. None of that's required for this talk. And we're here to talk through a fake outage and hopefully have some fun in the process. So let's get started. Let me set the scene. So the backdrop is Yarnit. Yarnit.ai is an online web shop for all your knitting and crocheting needs. So Yarnit sells yarn of all kinds, and that's the single largest variety of product that we carry. We sell knitting needles and patterns, so many patterns for sweaters and hats and socks and plush toys and all manner of creations. And we have a lot of user-generated content and user recommendations as well, very active user base, international, but we tend to sell the majority of our products in northern climates because northern climates or some of the mountainous southern climates, especially in South America, simply because those places are the places that have the largest cultural traditions of knitting. Okay, so how do we use machine learning so you can sort of have this in your head? Well, we use machine learning to rank search results. So a typical search system takes some words, goes to do just some pattern matching of a bunch of documents or products that have words or words like those words. But the key part is the ranking. Which of those plausible results is the best result? And we use machine learning to do that. A bunch of different features you can imagine. There could be the results, other people who have done this query have preferred these results. It could be the query context. What were you looking at before you did this? Or other queries that this user has made, products that this user has purchased, which part of the world the query is coming from, et cetera. So we do that. And then we also have a discovery user experience ML application where in various contexts on the site, whether you're logged in on the homepage, you're logged in and you just come to the homepage, or you're just browsing and you're looking at one product or added a product to a cart, in all of those circumstances, we'll give additional recommendations for things you might want to look at since you're looking at this thing or since you have bought these other things. We use an ML model for that as well. Okay, so here's where the story starts. It is a warm spring day. Many good stories start, it's a warm spring day. It's a dark and stormy night. No, this is a warm and sunny spring day. In fact, it's an unseasonably warm spring day. It's been warm for actually a couple of weeks now, much earlier than expected. And Gabi, our ML engineer, although is cranky about climate change, is sort of quietly enjoying the nice day as well. So it's a little bit of a conflicted state there. Gabi's in the office or at their desk settling down to catch up on bugs and work through a backlog of a few issues. And two internal escalations show up at the same time. And by escalation, I don't mean pages. Our automating system has reported that there's nothing wrong, but two internal escalations do arrive. One of them is from support. It says customers are complaining about weird search results. Now, I'm not going to throw support under the bus here. I'm not going to complain about them and say vague problem report. Support's dealing with outside users. And so vague problem reports are sometimes the best they can do. And they do apologize for this. They say, we know this is kind of a bogus, hard to understand report, but we're getting enough of these that we thought you should know. The problems are vague. We can't really see a lot of commonality among them. But the customers are right. They're getting weird search results. We can reproduce it. When they look for those words, they get weird results that aren't the right kinds of things. We can give you a bunch of examples. It's been going on for a few days, maybe several days, maybe a week. We're not actually sure when it started, but it's getting worse, and that's why we noticed it. I was like, oh, great. Sounds really complicated. Okay. The second thing that happens within the same hour, not at exactly the same moment, because that would be creepy and coincidental and would make this whole story implausible, when so far it's so plausible, right? Right? It's plausible, trust me. Finance contacts Gabi and says, hey, by the way, we're making less money than we expected to by like a modest amount, by a few percent, maybe as much as 5 or 10%. We're actually not sure, but we're starting to get concerned. Well, this is odd. This is not good. They haven't localized it yet. They don't know if it's one particular country. They don't think so. Any particular vertical, particular time of day. And they can't really figure out when it started, but they have an expected value of revenue that takes into account, the day and the day of year and the day of the week. And so they compare, today versus yesterday, this today versus same day last week, today versus same day last month, et cetera. And it's not, and it's today versus same day last year. It's down from what their model had predicted. So, okay. So we have an incident, right? The incident has started. So here comes audience participation. Are you ready? This is going to be so great. I don't know if it's going to be so great. We're going to try it. So here's how it works. I ask a question. I describe multiple choice answers. There are other ones. I picked some. You pick one. You can either pause the video or just follow along at home and pick your answer quickly. I'll give you a moment. And then it's the honor system. And the prize is bragging rights. So after this session, I understand there will be a Slack session. I'll try to show up there. If you message me and you tell me that you got it right, I will publicly acknowledge and convey bragging rights. And these days, bragging rights are pretty good rights. So just saying. Here we go. Are you ready? Got something to write with? File to take a note in? Okay. Question number 1. What connection is there between these two reports? So first possibility, there's a recently updated and broken machine learning model for recommendations. That's entirely possible. We get models wrong all the time. So in this case, it would be that we had a machine learning model that's new and it's not as good as the old one. We just did a bad job. Okay, so that's possible. Problem number B, there's a problem in serving. So the model itself is fine, but the configuration of the serving system, something about it isn't suited for this model. So there's lots of specific kinds of things that could be. You don't need to worry exactly about what they are, but you can sort of imagine. And if you have some of the basics of how these things work in machine learning, it could be like feature retrieval or feature definitions are wrong, or in particular that there's a training serving feature definition mismatch, which could be something as small, although this is quite big, as quantization differences, or it could be something as significant as like just completely redefining a feature to semantically be something else. So that's that. C, it could be a stale model. So I didn't mention this, but Yarnit updates their model once a day. We've found that once a day we update our model and it sort of keeps up to date with changing user preferences over time. Maybe we haven't updated the model or haven't updated the model in a long time or long enough. And so that's what's going on. Okay. D, I wouldn't have said D before this fairly terrible last couple of years we've had, but perhaps it is a complex global supply chain problem. So something to do with the Ever Given getting stuck in the Suez Canal, or there's a chip shortage. I have no idea how these things caused toilet paper to run out in many parts of the United States. But what I'm saying is now that COVID's in place, that has to be in the solution space of any troubleshooting of any retail operation. Global supply chain problem. Okay. E, all of the above or some combination of the above. That's always good. F, none of the above. Like these things wouldn't or shouldn't or can't have caused that. G, no clue. There's not enough information. The question is unfair. I plead the fifth, whatever. To be fair, G is probably the right answer. I actually don't think I've given you enough information to really make an appropriate guess, but we're still having fun here. So don't pick G. Don't pick G. Okay. You ready? We'll take a minute. Go back and look at the options again. Okay. So what is the answer? Everybody's recorded their answer. Just kidding. I'm not going to tell you the answer yet. Hold that thought. It's no fun if I just tell you the answer. Let's actually instead do the troubleshooting, because that's what we do, right? What we do is every page is a mystery, right? Every page is a tiny little mystery just for you on your on-call shift, just a gift for you to explore. I know it never feels that way, but that is actually true. And so as a result, let's take this for the mystery that it is, and let's just savor it for a minute and talk about how we would troubleshoot it. So what do we do? Well, Gabi's going to have to go talk to almost everyone. Not quite everyone, but let me tell you why. Machine learning outages often involve a larger portion of our organization and a more diverse portion of an organization than other systems outages. There's a few reasons for that. And there's limited time to explain all of them. But one way to think about it is right now, machine learning is complicated and machine learning is expensive. It's expensive in terms of the people talent to make it work. It's expensive in terms of the machines to produce the models. So as a result of being complicated and expensive, and also a little bit finicky and confusing, organizations are deploying machine learning only in those cases where it's worth a lot to them. So very few people are saying, like, let me deploy machine learning to figure out how to sweep my floors. I say that example, but of course, I'm sure Roomba does. But most of us, we're like, just sweep the floor, use some heuristic. Most of the things that are simple that we can kind of solve already without machine learning, we just solve without machine learning. It's fine. What we see is machine learning is used for very significant problems where the benefit can be huge, but those problems, those systems then have stakeholders across the organization. Why? Because they're significant and they have huge benefit. Okay, so Gabi's going to go talk to support because support reported the problem. They've been talking to the customers. We need more information on the types of outages that they are seeing. Fine. Gabi's going to talk to finance. That's fine too. Finance reported it. Maybe we can get them to narrow down how much money is being lost. So we need more information. We're going to talk to the modelers, the people actually building the models, and talk about what they've changed recently and what they were looking for and what they expected. We'll talk to SREs who deploy the models in production and run those systems and write the monitoring for it to see if they've seen anything odd, change their monitoring, whether they've changed the configuration of the serving system in any way. Gabi's also going to want to talk to the retail managers. So retail managers are responsible for the products that we purchase and how we market those products. And they may know something that has changed as well. So what does Gabi find? Okay, well, early findings, not having gotten answers back from all of these folks, are, well, the model config is stable. So the modeling engineers say, we have a bunch of ideas we're working on, but the model that's in production is the same configuration as we had a month and a half, 2 months ago. We haven't updated that recently. Okay, so, but Gabi's like, yeah, but have you retrained it recently? And they double check and they're like, yes, the model has been retrained every night for the last night. And the one that you have in production is same configured model, same model architecture, same model configuration, same hyperparameter weights, et cetera, but trained on new data that has arrived, new user data. We usually train on clicks and queries and, events that happen on our website. Okay. Well, that's too bad. It could still be a problem with the data, but we're ruling out options here. Okay. The SREs say there's no serving errors and there appears to be no changes in definition of features between serving and training recently. Okay, so what does all that mean? Well, it means it's probably not a broken model. It's probably not a serving mishap of some kind, and it's probably not a stale model. Okay, it could still be lots of other things, but to try to narrow down the options, Gabi grabs their colleague Imani, and Gabi and Imani have a great idea. They're like, let's back way up. Let's grab 100,000 user queries from basically today or yesterday, 100,000 user queries from 4 weeks ago. We'll look at the queries, the answers to the queries, and we'll compare those in those two sets and see what's different. Now, of course, they're all different because we don't get the same 100,000 queries ever. But by what's different, I mean, are there significant changes in the distribution? And we can look at those on source countries, retail product verticals a little bit, although we don't really have great product verticals, but are people looking for yarn? Are they looking for needles? Are they looking for patterns? Are they looking for other accessories? Are they looking for, completed clothing products or something like that? So at least we have coarse grained things of those. And then we can look on price bracketing. for the queries and the responses. Okay, so question number 2, what will they find? Option number A, the queries are similar, but the answers are different. This would indicate that the model has changed. The models are the same, so the answers are the same, but the queries are different. This would indicate that the users have changed in some way. What they're looking for is fundamentally different. C, the models and the queries are different, so questions and answers have both changed. That's possible. That would be both hard to detect and also really confusing and frustrating, and we would be left to go think about this harder again. D, everything's the same, and this is a complete troubleshooting dead end. Option E, fun option, grabbing 100,000 user queries without careful and thoughtful anonymization and privacy control has pretty serious privacy implications and is now a problem for the incident investigation. Option F would be A and E. Option G would be B and E, and option H would be C and E. There's a heavy hint here that there's something about E. I'm just going to give it to you. E is just true. So let's talk about that. I don't think you probably saw that coming, but let's have a brief privacy interlude. So I'll give you a moment to record your answer. Has everybody had a moment? Okay. If you've recorded your answer, let's move on and talk for a moment about privacy. I will make the bold, I don't think controversial claim that machine learning incident response requires privacy infrastructure. So E is just true. Viewing user queries is sensitive and it shouldn't be done without privacy controls. Now, I'll admit in the story, I didn't tell you that there were no privacy controls, but I did pretty directly imply it by saying they went and grabbed a bunch of user queries. So why is this a problem? Well, so first of all, user queries are sensitive information to users. It's really nobody's business what users are looking for other than their own, and protecting that user data is really important. Now, broadly speaking, machine learning systems train on sensitive user data. And as a result, they often have direct access to private user data and use that user data, set to benefit those same users. There's not a problem with that, but there is a problem with not controlling access to those data and not logging sensitive access. So during an incident, just as we see here, production engineers may genuinely need to see user data. And actually during model development, model developers may need to see examples of user data when they're getting strange results and they need to compare, like, why is the model working the way it does? That sounds fine. They should only see these in a controlled, logged, and overseen fashion. And what do I mean by that? Well, here are some super simple best practices that most organizations can find a way to implement. So by default, no access to user data. Secondly, non-emergency access to user data. So the model engineer should just be reviewed by privacy experts and overseen by them. So if you need to see the data in order to build your model, that's fine. Talk to a privacy expert in your organization, someone whose job is not building a model or running the model, and they can help you do that in the safest way possible and ensure that they oversee your use of those data. Thirdly, emergency access. I mean, you shouldn't wait for a privacy review for emergency access, but once you declare an emergency, your access should be logged. Everything you do with the data after that point should be logged, and that should be reviewed as quickly as possible by someone in privacy. And the fourth is you should save yourself all of this hassle by anonymizing as much as possible, wherever possible. So there are some really sophisticated but useful techniques to collect groups of similar bits of data. It's tricky because if you don't know what's similar about them, then it's tough to know if they're similar enough to combine. So I don't want to pretend that that's an easy approach, but there are some good technologies there and you should look into them. Okay, fine. That's my rant on privacy. Please do take it seriously. So what's the answer? Well, here's what actually happened. What actually happened is climate change. You knew this, right? This was going to happen. Temperatures got warm. User demand shifted to lightweight yarns. So for those of you who don't knit or crochet, when it's hot out, if you have like really thick yarn on some like woolly jumper you're knitting in your lap, it's not comfortable and you don't like it. And so fairly quickly, people in warmer temperatures or people in like temperate climates that get warmer shift to lightweight crocheting, and they want to knit with hemp and cotton and silk and, you know, other lightweight yarns. Well, Yarnit, at the same time, Yarnit's best supplier of lightweight yarns was out of stock of almost everything, in part because demand shifted so quickly and pandemic supply chain challenges. So as a result, the search and recommendations models are making weird results, the best ones, because we just don't have products in stock, and they don't recommend products that aren't in stock. And the revenue declines, not because our model is terrible. It's unclear whether we could do better than we're doing now. We probably could, but we just don't have the product that people want to buy. And at some point, if you're a store and you don't have enough of the product people want to buy, you can't sell it. So no part of this outage was caused by machine learning. Arguably, we didn't do anything wrong, although we had many opportunities to know about this sooner, and there were probably some opportunities to do better than we did. That's a little bit different from saying we did something wrong. Okay, so the correct answers are, for question 1, D, a complex global supply chain problem. I don't think this was a plausible guess. I'm sorry about that. I didn't say you could answer these questions, just that I was going to have fun. Here I am having fun. Question 2, G, was the correct answer. So the queries had changed, and we also committed some privacy risks by just looking at user queries. So what are some takeaways here? Well, machine learning is sometimes weird. So sometimes machine learning outages are very similar to just other distributed systems outages. And sometimes machine learning outages are really odd. And they're characteristic of a mismatch in our model and the world more than something fundamentally broken about our model. And this is a case of that. Machine learning models are also, or machine learning systems are also harder to monitor. In particular, when we say we want to monitor the functioning of a machine learning system, as you saw, we rapidly go to monitoring it end to end. So what is the final result? Is it doing its job, whatever that is? So if you think about a search ranking system, determining that whether it's doing its job would require ranking a bunch of search results and looking at what we objectively think is the quality of those rankings. Well, here's a case where the rankings got bad because the products were out of stock. But even if we had been monitoring that and we had seen that happen, it would not necessarily have meant that the problem was in the machine learning model. It's also because model developers are always trying to improve models. It's not obvious when the model is in fact broken or whether it could just be better. And then the interesting third point that I want to take as a takeaway, and my colleague Kathy Chen has a good talk on this, I think later in this session, but machine learning systems span whole organizations. So people deploy ML, as I said, where it matters. And so when it matters, we tend to take inputs from and have stakeholders in the entire organization. I mentioned that we're writing a reliable machine learning book for O'Reilly. I'm writing that with Kathy Chen, who's talking here at this conference, as well as Niall Murphy, Kranti Parissa, and the inimitable one and only Dee Scully. Many of you have read many papers of his on machine learning operations management and development over the years. So there's a link to free access to some early release chapters that should be out now if you feel inclined to look at them. One of them is the incident management chapter that this talk was developed from. So with that, I want to say thank you for your attention. I told you we would have fun. I had fun. I'm going to pretend you have fun in the future there where you're watching this. I really appreciate your time and attention and look forward to hearing from some of you in the future. There's my Twitter handle. Feel free to follow me for no reason whatsoever, but you're welcome to if you want to. And I'll certainly send information more out about the book when it is available. Thank you so much.